Example 9.3.3, finding the net present value, or NPV, in IRR, or internal rate of return, of a multi-year project. All right, the setup for this one says, you are evaluating a potential project for your firm. The project requires an upfront investment of $1 million and will generate cash inflows of $220,000 at the end of each of the next 5 years. You estimate the project's risk-adjusted cost of capital at 8%. What is the project's NPV? What does the NPV decision rule say about this project? There should be a question mark there. And what is the project's IRR? And what does the IRR rule say about this project? Okay, so from the early examples, we know net present value and internal rate of return are time value of money calculations. So we're going to start out by drawing the timeline, which I've actually just stolen from the text right here, where the initial cash outflow today at time period 0 is going to be $1 million. That's going to be followed by 5 consecutive cash inflows at the end of each of the next 5 years, and our cost of capital is 8%. All right, now we've got to calculate both the net present value, or NPV, and the internal rate of return, or IRR. Doesn't matter which one you do first. I'm going to start with NPV, since those two are closely related. And eventually what we're going to do is use this net present value definition, where net present value is equal to the present value of the benefits, that is the cash inflows, minus the present value of the costs, that is the cash outflows. And so what I've got to do is figure out how to calculate the present value of the cash inflows, the present value of the cash outflows, and then look at the difference between those two. So what I want to do is follow that familiar three-step process from earlier in the text and look at what type of cash flows I am dealing with here. First off, we see that the cash outflow, the single cash outflow, is already at time period 0. It's in today's dollars, so it's already in present value terms. No adjustment needed there. That is the present value of our costs. Now the cash inflows don't occur until a future time, and there are 5 of them. It's the same cash flow at the end of each period. So it's a level cash flow, regular intervals, and it stops eventually. So what we're looking at here is an ordinary annuity. Right? And once we've identified it as an ordinary annuity, we know we've got 3 tools we can throw at it. We could use the present value of an ordinary annuity formula. We could use the time value of money keys in the financial calculator. Or we could use a spreadsheet, which we've just been looking at formulas and calculator solutions since we can't use a spreadsheet on exams. I'm going to introduce a different tool here. We could indeed use the time value money keys in the calculator. And in fact, the solution has you kind of walking through both. But just to see, let's glance at the text, just can see what's involved if we wanted to do this by hand. All right, so if we wanted to go for the formula solutions, we would, of course, identify this thing as an ordinary annuity, and this is the formula for the present value of an ordinary annuity from the previous chapters. All right, introduced in Chapter 4, used again over and over in Chapter 5, and we would use that for the present value of the benefits, and then subtract the present value of the costs, which of course are just the $1 million. So if we wanted to go through that by hand, it would look like this. We'd filter through all those formulas. We'd figure out that the present value of that $220,000 5-year annuity is $878,000 and change. We subtract the $1 million from that, and we'll get a negative net present value of $121,603.79. Right? That's if we wanted to use the formulas. Now, if we wanted to calculate IRR and do it by hand, we would use the exact same setup, but recall that IRR, internal rate of return, is the rate at which net present value equals 0. So we would set up the same net present value equation, set the NPV equal to 0, and then find the rate that makes this statement true. Now here's why I'm going to skip past the formula solution and just go straight to the calculator to solve for this. And that's because there is no way to solve for this with algebra. You're not going to solve for R. You're not going to get it by itself. The only thing you can do is an iterative method. So just kind of look at it and go, gosh, I don't know, let me start with 10%. So you plug in 0.1 for R, see if it happens to make this thing equal 0, And depending on if the number comes out positive or negative, you make a higher or lower guess, and you just keep going until you get it right. Now, the calculator can do this very quickly, and in fact, there's a function in the calculator that can give you both net present value and internal rate of return very quickly. And so we're just going to go straight for that rather than even using the time value of money keys there. So let's look at how to do that. All right, so we've got our cash flows here. We're going to open up what's called the cash flow worksheet on the BA2 Plus. And the way we open that up is with the CF button that is just to the right of the second key. So I'm going to press that. And this is going to open up something like a mini spreadsheet in the calculator. Now, just like the time value money keys, this thing is a memory function. So you can see when I hit the CF button, it pulled up values. The last problem I worked is still stored inside of the CF function. So just like the time value money keys, I want to clear this thing out before I start a new problem. Unfortunately, to clear it out is a slightly different process than the time value money keys. We're still going to start by hitting the second key, and then we're going to go all the way down to the bottom left and hit the clear work key. All right, so to clear out the CF menu, we first open it by pressing CF, and then we hit second and clear work to zero everything out in the cash flow worksheet. All right, now one thing that's cool about the cash flow worksheet is, unlike the time value money keys, you actually enter it just like your timeline appears. All right, so CF0 is the first entry that comes up, and CF0 stands for what is the cash flow that happens at time 0. And with this particular investment, that is a cash outflow of $1 million. So what I'm going to plug in to the calculator here is a negative $1 million. All right, so I will type in 1 million. And then I will press the plus minus key to make it negative. And here's the part that can be difficult to remember when we first start using this. We have to press the enter key to store that value on CF0. And when we press the enter key, our display changes a little bit. We get the equal sign. We get some decimal places, however many it can show us, up to how many we have it set to display. And then we get that sideways triangle to let us know that it is a stored value. All right, so the thing that is easy to forget is to remember to press that enter key. All right, once we've got that value stored, we see our sideways triangle there. We can go to the next entry. That is the cash flow that happens at the end of the first period. And to do that, we're going to press the down arrow key to go to the next entry, right, which is just to the right of the on-off key. All right, so we entered our negative 1 million, we hit the enter key, and then we're going to press the down arrow key. And that brings us up to the next entry, which is CO1. CO1 stands for cash flow 1, or what cash flow happens immediately after cash flow 0. In this particular example, that is a cash inflow of $220,000. So I'm going to type in $220,000. And then I'm going to press the enter key to store it. And once again, you see the equal sign come up, the decimals, and the sideways triangle. Okay, so we typed in a positive 220. And we pressed the enter key to store it. And then we're going to press the down arrow key to go to the next entry. So press the down arrow key, and now we get something a little bit different. We get F01 as the next entry that it is looking for. Now the F entries stand for frequency. And this particular one is F01, so it's referring back to cash flow 1, and it's saying that number that you just put on cash flow 1, that $220,000 that we stored there, how many times in a row do you observe that exact cash flow, right? With this problem, we see the cash flow once, the end of year 1, a second time, the end of year 2, a third time at the end of year 3, fourth time at the end of year 4, and a fifth time at the end of year 5. So rather than entering 5 different cash flows that are all $220,000, what I can do is just say, hey, that frequency of cash flow 1 that I put in, that $220,000, I actually see that 5 times in a row in this case. So I'm going to type in 5 for FO1 and then enter to store that value. All right, and since I set frequency of cash flow 1 to 5, we have taken care of all 5 of these cash inflows of $220,000, and so we have now entered the full timeline for this particular investment. Now, what I want to do is calculate the net present value and internal rate of return of these cash flows. But before I do that, I want to make sure that just the cash flows that I put in are really the only ones that are recorded. Because remember, this is a memory function, and I've had bad luck for thinking I cleared it out and I didn't, or something like that, and the stuff will still be in there. So to check that, what I like to do is go ahead and keep hitting the down arrow key about 3 times after I put in the last frequency. And by default, see, cash flow 2 is 0. That's a good sign. There's nothing recorded there. I'm going to hit the down arrow key again. FO2 is now also 0, and by default, those frequencies are set to 1. So seeing that 0 there tells me that there's nothing beyond that. And if I hit the down arrow key one more time, if that's true, there's nothing beyond it, it should take me back to cash flow 0. Let's see what it does. Okay. Hit the down arrow key the 3rd time, and I'm back at cash flow 0. So now I'm confident that those cash flows that I put in are the only ones in there that it's going to use to calculate NPV and IRR. Okay, so to get NPV, we'll go after that one first, and it doesn't matter what order you do these in. I'm just going to go for NPV first because that's what I feel like doing at the moment, and that's what the text example does. When I press the NPV key, the calculator comes up with I equals. Remember, to calculate net present value, we've got to find the present value of all those cash inflows and then subtract the present value of that cash outflow. So we press that NPV key, and the calculator came up with I equals. So it needs a discount rate to find the present value. Now, what we use to calculate the present value for net present value calculations is what we call the risk-adjusted cost of capital. In this case, that's 8%. And just like your I over Y key, the I function is expecting a percentage here. So we put it in as a whole number and not a decimal. So when I type in 8 and press the Enter key to store it, it records 8 on I, and it knows that that is 8%. So we do not have to enter it as a decimal in this function, just like the I over Y key. From here, I need to get back to the net present value function. You can press the up or down arrow key. It doesn't matter. I've been using the down arrow key, so I'm just going to hit the down arrow key again, and it comes up now. It says NPV equals, and we get this compute prompt on the top right. The calculator's telling us that it has enough information to compute the NPV. Do we want to do that? And yes, of course we do. So we can press the compute key, CPT key, up on the top left, and it will do that calculation for us. And we will find, just like we saw when we looked through the algebra work in the example, we get the same value back, that NPV is equal to a negative $121,603.79. Okay, so we got a number back. That's great. What does that number mean? Now, the NPV decision rule is if NPV is positive, that means that, remember, net present value is defined as the present value of the benefits minus the present value of the costs. So if the number we get back comes out as a negative, that means the present value of the cost was higher than the present value of the benefits, right? And that means if we were to invest in this project, we are expecting to give away value. So we're taking our financial stakeholders' capital, we're investing in this project, and we're actually losing a little over $121,000 worth of value that the financial stakeholders have handed over to us. So we would reject this project, right? Since NPV is less than 0, the NPV rule says to reject this project. We would not take it, because if we did, we would be destroying value. All right. Now, we saw when we were looking through the algebra and the text that if we wanted to calculate IRR, we'd have to set up that NPV equation, set NPV equal to 0, and then try and find an R that made it true. And that's an iterative process. We just have to guess and guess and guess until we got close enough. Now the calculator is going to do the exact same thing, but it can do it a lot faster than we can do by hand. So to get the internal rate of return now, what I'm going to do is I'm just going to press the IRR key on the calculator. And here it comes right up with IRR equals, and we've got the compute prompt. Because it doesn't need a discount rate here, it's going to try and solve for the rate. So we press that IRR key, and then we can go straight to pressing the compute key, and it's going to do a very quick iterative process to come up with an IRR. So we press that compute key, and we come up with an IRR equal to 3.2635, and it's giving that back to us in percentage terms because it knows that IRR is reported as a percentage. All right, so now the last question that we had to answer with this example is, what does the IRR rule say about this project? Well, the IRR rule says that we accept projects with an internal rate of return greater than the cost of capital. So in this case, our internal rate of return was 3.26%. All right, and our cost of capital, right, what it's costing us to use our financial stakeholders' money was 8%. Right, so if we're not earning at least 8% on a project that we're looking to invest in, then we're not earning enough to be able to pay the expected dividend on the preferred shares, the expected rate of return on common equity, and we're not earning enough to actually make the coupon payment on our debt. So if that internal rate of return is less than the cost of capital, then the IRR rule also says to reject this project. All right, so in this case, both rules agree. We come out with a negative net present value. So net present value rule says to reject, and we come up with an IRR that is less than, I drew our greater than, less than symbol backwards there. We come up with an internal rate of return that is less than the cost of capital. And so it also says to reject this project.